Okay, welcome back. So this is the second example of how we differentiate parametric equations. It's a little bit trickier in this question because the first you're being asked to find the normal. So we're not just finding the gradient, we're doing something with that gradient. And the functions are in terms of theta, which is no different to a t, but it just looks a little bit different. So how you approach this question is exactly the same. You see the word normal and you think, oh, I need the gradient of the tangent, and then I can use the reciprocal of the gradient to find the gradient of the normal. So the first thing you want to do is differentiate dx by d theta this time, because it's theta is going to be equal to 3 cos theta, because the differential of sine is cos, and dy by d theta is going to be equal to minus 5 sine theta, remembering that cos goes negative. So then we know that dy by dx is equal to dy and dx, and then we want to build it like this. So we know they would cancel, so that's definitely true. So my dy by d theta was minus 5 sine theta. My reciprocated dx by d theta upside down would essentially be 1 over 3 cos theta. Well, this would simplify to minus 5 over 3 sine theta over cos theta, which is just minus 5 over 3 tan theta. So we've found the gradient function, but we haven't finished the question because it's asked us to find the normal. And we're looking at when theta equals pi by 6. So we can just sub that in. My dy by dx would be equal to minus 5 over 3 times by tan of pi by 6. Hopefully you realise that tan of pi by 6, well, to turn that back into degrees, we just do 180 divided by 6, which gives us 30. So this is just tan 30. And hopefully you remember that tan 30 is equal to 1 over root 3. If you didn't, you could use your calculator to do that, but you'd obviously want it on radians mode. So your gradient is minus 5 over 3 root 3. That, however, is the gradient of the curve. So if your curve is like this, that's the gradient of the curve. We want to find out the equation of the normal at that point. So we're going to need to find the reciprocal. So gradient of the normal, remember it's the negative reciprocal, so the sign changes and it turns upside down, 3 root 3 over 5. And then we need to find the equation of a line. We need two things. We need the gradient and a point. Well, we don't actually have yet a point because we've only got a value of the parameter, so we need to sub that in too. So when theta equals pi by 6, x is equal to 3 sine of pi by 6. Well, that's just sine 30, which we all know is a half, so that's 3 over 2. Y is equal to, we take our equation for y, which was 5 cos theta, so it's 5 cos pi by 6. And then that would be cos of pi by 2, which is root 3 over 2. So we end up with 5 root 3 over 2. And then it's just a case of subbing that into y minus y1 equals mx minus x1. Y, remember here, is the variable. My y1 is my y coordinate, so that's 5 root 3 over 2 is equal to our gradient, which is here, 3 root 3 over 5, times by our variable x minus our x value.